Chicken sticky rice is a traditional Thai dish composed of glutinous rice and domesticated chicken. The glutinous rice, characterized by its high amylopectin and low amylose content, exhibits a sticky texture upon steaming, which facilitates manual consumption and adhesion of ingredients. The chicken component is often marinated in a solution containing sodium chloride, reducing water activity and enhancing flavor through osmosis and Maillard browning reactions during grilling or frying. It is one of the most famous dishes in the Faculty of Engineering of Chulalongkorn University. As you walk into the canteen and order one freshly cooked,
now guy visit Nim Krub,
and finally sit down with your lunch, you feel an ominous aura behind you. Yes, in front is your chicken sticky rice, but it won't be for much longer, because it's about to be stolen. But how, you think? I've already protected it by covering it with my hands and guarding it with my own eyes. You've already answered your own question. Gone are the days when you could protect your food with mere human capabilities. In the canteen, the enemy has evolved. The thief, once a humble street pigeon, is now an apex predator of the modern food chain. No longer does it clumsily flap in front of your meal. It employs distraction tactics. It passively tracks your movements with its panoramic vision, slowly learning your behavior patterns with advanced pattern recognition techniques to detect, identify, locate, and intercept your lunch. And before you even realize, it had already eaten the food on your plate. And so, we adapt. With the rise of this avian threat, the defense of your lunch has entered a new era. The era of nanotechnology. Today, we will show you how to protect your chicken sticky rice and other lunch items from pigeons by using the latest nanotechnological solutions. Our first proposed countermeasure to this threat is to prevent pigeons from loitering around our canteen in the first place. Pigeons tend to perch in high places before attacking. The second floor railings, support beams, and concrete ledges in the canteen are prime perching spots. Since we know that pigeons rely on secure footing to land and perch, our approach is to make the surface that they land on to be unstable or unwelcoming. With the nanotechnology approach, we can make this possible without having to rely on aesthetically horrifying anti-bird spikes or barbed wires that could make our canteen look like a prison. We can start by implementing slippery coatings onto the support beams and ledges. These coatings can either be made from superhydrophobic nanomaterials, such as silicon oxide functionalized with fluorosilanes or alkylsilanes. Superhydrophobic surfaces are engineered to repel water and reduce adhesion. This is achieved by creating micro and nanoscale roughness on the surface, combined with low surface energy materials like fluorosilanes. The roughness traps the air, minimizing the contact between the water droplets and the surface, leading to high water contact angles and low sliding angles. Such surfaces are inspired by natural examples like lotus leaves. Another material that can be used for making slippery coatings are nanocomposite polymers such as PTFE embedded coatings. Nanocomposite polymer coatings incorporate nanoparticles into a polymer matrix to enhance surface properties. PTFE, which most of you may know as the non-stick coating on your pan, has very low friction and non-stick characteristics. When embedded into these coatings, PTFE nanoparticles reduce surface energy and increase hydrophobicity. This results in surfaces that are more resistant to adhesion and easier to clean. These extremely slippery coatings can be applied onto the surfaces and prevent the pigeons from perching and planning their attack against our lunch. If the pigeon manages to hang around, our second line of defenses involve embedding nanosensor arrays around your eating area, such as on tables, railings, or columns. Through the usage of an optical nanosensor made from either quantum dots, silica nanoparticles, or optical fibers coated with gold nanoparticles. Quantum dots are semiconductor nanocrystals that exhibit size-dependent optical properties due to quantum confinement effects. When excited by light, they emit fluorescence at specific wavelengths, which can be finely adjusted by changing their size and composition. These tunable fluorescents allow quantum dots to act as sensitive detectors for specific optical signatures, such as the UV reflectant characteristic of pigeon feathers. By monitoring changes in their emission properties, quantum dots can help us detect nearby pigeons. Silica-based nanomaterials can enhance the optical scattering used in sensors. By doping fibers with silica or other nanoparticles, the scattering intensity can be increased, improving sensitivity. In the form of fiber optic cables laid along perimeters, it has been shown to successfully detect the acoustic vibration of animals. For example, a study showed that a buried fiber could provide early warning of approaching polar bears at Arctic research camps. This concept could be extended to smaller animals. In our case, a nanoparticle-enhanced fiber could sense the movement of birds landing on structures. For gold nanoparticle-coated optical fibers, they take advantage of the phenomenon called localized surface plasmon resonance, also known as LSPR. When light interacts with gold nanoparticles, it induces collective oscillations of electrons, which are highly sensitive to changes in the surrounding environment. The presence of a pigeon can alter the local refractive index near the fiber surface, causing measurable shifts in the LSPR signal. This change can be detected and used to confirm the bird's presence. These optical sensors can be set up to detect pigeons. Once they have detected the threat, it can then send optical or electronic signals that trigger nearby acoustic devices to transmit ultrasonic sounds, which can drive away the pigeon, successfully defending our lunch. If the pigeons manage to penetrate this second line of defenses, the pigeon is likely going to be near your food, at the table, just moments away from snatching your lunch. At this point, no nanotechnology-based approach can help you. You are now left with no choice but to engage in hand-to-hand combat with the enemy to defend your property. And in the end, while nanotechnology offers advanced solutions, sometimes the most effective defense is a well-timed human reaction.
Would you please kindly go away? I don't know how to animate a fight scene.